Let's look at what negative exponents are and what they indicate. As in positive exponents, back in these previous examples, there is a repeated multiplication of the base within negative exponents. So let me write that in there. Negative exponents indicate repeated multiplication of the base with a slight difference. Let me show you first, and then we'll fill in those lines. 5 to the third power really means 3 5s multiplied together. Repeated multiplication of that base. So 3 5s multiplied together will give me that amount. 5 squared means repeated multiplication of that base, or 5 times 5. 5 to the first power has a value of really just 5, and from a previous activity, 5 to the 0 power has a value of 1. Any number raised to the 0 power is 1. So in order for this pattern to be true, or let's look at this pattern anyway, the values of these exponential terms whose exponents are decreasing by 1, these values, there's a pattern here, and hopefully you see it. If you take this 125 and divide it by 5, you get that. If you take this and divide it by 5, you get that. If you take this and divide it by 5, you get 1. Well, hopefully I can have you buy into this idea. 5 to the negative 1 power, the next value here should be that divided by 5. And it is. 5 to the negative 1 power means 1/5. So right away, a negative exponent of a whole number base anyway means there's a fraction going on. Okay. 5 to the negative 2 power. Well, if this pattern is going to be true here, then we should take that value and divide it by 5. If you remember your fractions, or at least multiplying, you can think of this as over 1, or I'm sorry, multiplying and dividing fractions. If you remember that, think of this as over 1, and then to evaluate, we multiply by the reciprocal. So 1/5 times the reciprocal of that second guy, which is this. And so what we have here in multiplying fractions, remember, it multiplies straight across. So we get 1 times 1, or 1, and on the bottom we get 5 times 5. So let me stop you here and say this. Negative exponents is a repeated multiplication of 5, 2 of them in fact, but that multiplication is occurring within a fraction whose numerator is 1. So that's the idea here. And if we were to multiply that out, we get 1 over 25. So again, I want you to make this connection between this and this, which I'm going to write as 1 over 5 squared. Let's do another one, 5 to the negative 3 power. So that is our value here of 125. If we're going to make this pattern work, we would take our previous value and divide it by 5. So again, think of that as over 1. To evaluate, multiply by the reciprocal. So if we multiply straight across, we get 1 times 1, 25 times 5. And I'll write it this way, 1 over 5 times 5 times 5. That also can be written as 1 over 5 cubed. Now why did I write that? Well, let me show you. 5 to the negative 3 power means there's 3 5s being multiplied here, but it's occurring. That negative means do it in the denominator of a fraction whose numerator is 1. So a negative exponent means there's a fraction going on. That's my point to you. And we could write it this way in a shorthand version, but this would be the value of it right here. So negative exponents indicate repeated multiplication of the base within the denominator of a fraction whose numerator is 1. And in general, that's a 1, by the way. So in general, if I have a number base b, whole number, and I have a negative exponent, that means you take n b's, multiply them together, but do it on the denominator of a fraction whose numerator is 1. So b to the negative n power equals 1 over b to the positive n power. 5 to the negative 3 power means 1 over 5 to the third power positive. 5 to the negative 2 power means 1 over 5 squared, that being positive.